Okay. Now, so we'll have a look at section B now. So the first one here, can you write this equation down? X squared plus y squared equals x plus 1, y plus 2. Not working? Well, I'll read it out. X squared plus y squared equals brackets x plus 1, and then again brackets y plus 2. What the heck?
It's all from here.
Yeah, but who keeps doing that?
So one of Joyce torture.
Yes, it's all conclusion.
So I guess that's me.
Yes. Did you reach this?
Is that like a mentor? That's like.
No, it's just something to throw her.
I might be short, but don't underestimate me.
Alright, sorry, I don't mess with you, got it. Okay. Right. One more. There we go. Okay, so we write this equation down first. X squared plus y squared equals x plus 1 times y plus 2. So firstly, we want to find the derivative. So we have b1a, x squared plus y squared equals x plus 1, y plus 2. Alright, derivative now. 2x plus 2y y prime equals, and then product rule, so that's a 1 y plus 2 plus x plus 1, and then that's y prime in there. So this is 2x plus 2y y prime equals y plus 2 plus xy prime plus y prime. So grouping everything together, you get 2y y prime minus xy prime minus y prime equals y plus 2 minus 2x. So we're left now with the answer dy dx equals y minus 2x plus 2 here, and then 2y minus x minus 1 there. Yeah?
Would it be okay with x if we multiply with x plus 1 over?
Yep, that's fine too, yep.
Can't we do it like where we bring the x's to one side and y's to one side?
Nah, too difficult here. Doesn't work out nicely like that. Okay, I mean you could, but it's much more difficult that way. Now, the next thing is the curve cuts the y-axis at 2 points, A and B. Find these points. So in other words, where does this curve cross the y-axis? So if I want to find out where it crosses the y-axis, what would I need to do? X equals 0. You must have done so much work in the cafeteria, Brendan, that you've wasted all the ink in your pen. And that's the only reason you don't have a pen right now. It's not that you didn't come to school with a pen, right? Guys? Alright. So you put x equal to 0 to find out where it crosses the y-axis. So x squared would be 0. So you're left with y squared equals x plus 1, which is just going to be 1, and then multiplied by y plus 2. So when you put x equal to 0, you're just left with this. which is just a normal quadratic. Y squared minus y minus 2 equals 0. So this gives me two answers, y minus 2 and y plus 1. So you get y equals 2 and y equals minus 1. And remember, that's when x is 0. Got that? Yes? I noticed I lost Curdy since this morning. I gained Brandon but lost Curdy. Bad trade. Bad trade. Okay. Now what we have to do is calculate the slope at these 2 points. So we have a formula for dy dx. So it's literally just taking each answer and putting it back in. That answer first and then that one second. So first answer, you get dy dx, x is 0, y is 2. So that would be 2, and so that's a 4 on the top. And then that one there is 3. So there's the first one. And then the second one, x is 0, y is minus 1. So that would be 1. And then 1 over 1. So just 1 actually. So just sub the 2 points in, that's all. Oh no, wait, sorry, I don't think it's 1, sorry. 1 over minus 2 minus 1 minus 3, sorry. So it's minus 1 over 3. Okay, now the C part, the D part is probably a tangent or a normal or something. Oh, sorry, I'm not actually finished the C part. I misread it. Well, part C is, no, sorry, I've done the C part. This exam is not well read out. This letter D should be really up here because this sentence is actually part of this. So it says for part D, at 2 other points, the curve is parallel to the y-axis. Find the value of y at these points. So in other words, they're asking you to find out when the curve is parallel to the y-axis. Now that's kind of tricky when you think about it, because if the tangent is parallel to the y-axis, then what type of line is it? Yeah, it's vertical. So what type of slope is that? No, because 0 is horizontal. What are you going to say? Come on, it's one of those answers you always guess when you're guessing the wrong thing. And now when I actually need it, not 0, no answer, there is an answer. And not 1. No. What is the slope of the vertical line? There we go.
I said infinity.
Did you? I didn't hear you. Infinity. So when it's horizontal, it's 0. And when it's vertical, it's infinity. So when will this slope be infinite? What do you need to have infinity in your fraction? Yes, divide by 0. So in other words, you're looking for when the denominator is 0. Now, I actually think that was a very difficult part of the question. But again, at least it was the last part of the question. But I'm not finished yet because I need another equation with x and y in it. But that's okay actually, because we have another equation with x and y in it. It was the original one. X squared plus y squared equals, what was it, x plus 1 and y plus 2. Now, you've seen this in semester 1, but I can spot a little shortcut here. I can rewrite this as 2y equals x plus 1. Well, no, actually, I think the easiest thing would be to say x equals 2y minus 1, if I take the x to the other side. Then I can sub it in. So we have x squared plus y squared equals x plus 1, and that one there. And he only wants the y value, he doesn't want the x value. So actually you just need to solve this quadratic and you're finished. So this will be 4y squared minus 4y plus 1 plus y squared equals, well, they cancel, 2y squared plus 4y. So here I get 5y squared minus 8y plus 1 equals 0. Let's see what we got. 1, 1, y. I think this is going to be decimals. 3, 2. Yeah, unless I made a mistake, it's looking like it's decimals. Alright, so if you take out your calculator, please. You got your calculator?
Definitely.
So what are they?
1.5
Yeah.
and 0.1, 4.
Okay. So there are the two answers there. I can check if that's right actually.
So I think you get minus each way.
How do I get what?
Minus each way.
Minus 4y, and then I bring this to the left.
Okay, you cancel.
Nope. So this was 2012 version 2. Maths part 2. Okay. Did I get 2 and minus 1 for the B part?
Yeah.
Yeah, and then I got minus 1 over 3 and 4 over 3 is the slopes. So ABC is right. Yeah, it's decimals. He just left it in this form using. Remember I said in the exam you can't use the mode 53. So you have to, if you want, you have to use the formula which he did there, okay? But he didn't actually write it in decimals, he just left it like this. So that was okay to do it like that. But I would still say do the next step anyways and give me the decimal answer too, okay? How to use mode 53? Don't make the rules. That's just the way it is, I'm sorry. Whoa, slow down there, man. No, you can't use mode 53. I wouldn't give you the full marks if you just went from here to here, I wouldn't give you the full marks. You would need to do A equals 5, B equals minus 8, C equals 1.
Yeah.
What? 3 marks?
No, 8 is 3, not 5.
Yeah.
Oh, sorry. Well, we'll get with that in a moment. Is this one right? Did I write the same thing down here? 2y minus 1? Yeah.
Yeah.
Plus y squared? Yeah. Equals 2y times y plus 2. Right, so if I expand that, that's 4y squared minus 4y plus 1 plus y squared. So where's he got 3?
Yeah, it's 3 because...
Oh, I never took this one over. Alright, so that's just 3. Take the 2 over. 3 there. So that changes these two. Thank you. So look, if you wanted full marks, this is what you'd have to write down. You write down your ABC, and then you say y equals minus b plus or minus square root, 64 minus 4ac, so what's that, 52? Is that right? Yeah. All over 2a. Then you can give me the 2 decimals. But I need to see some evidence that you used the quadratic formula. Wait, I'll say it again. I need to see evidence that you either used the quadratic formula or you factorized. You can't factorize this. Is that answered?
No.
What's your question?
Can we just leave it at that?
For this marking scheme, it was acceptable, but I don't feel like it's acceptable all the time. So just so you don't lose a mark, you best give it as decimal too. I won't ever take a mark away if you gave me a decimal and the marking scheme didn't need decimal. I wouldn't take a mark away. So it's safe to give me the decimals. So what are the two decimal values here? Well, just put it in your calculator.
Can you draw this graph?
Yes, you want to see this funky looking graph, don't you? Well, Charles students know what it looks like, don't you? It's roughly a circle shape. It's not quite circular, this particular one, but it'll look circular in shape, I hope. That's why. What are you having trouble picturing? How the slope can be vertical, is it? Or?
And how it also crosses the y.
And how it crosses the y 2 times, yeah. X squared plus y squared equals x plus 1, y plus 2.
It's top of the circle and the bottom of the circle.
I think it might be perfectly circular or at least oval shape. Wait, I'll fix it up. Ah, yeah. There we go. So you see, it crosses the y-axis at 2 and minus whatever that number is, 1/4/3 or whatever it was. And then the two places the tangent would be vertical would be here at the far left, vertical tangent, and here at the far right. I think Derive lets you type in tangent lines as well, if I remember it. What is it? Tangent line 1 x. No, I don't know what. Well, what did I say the x was? You have to type it in your calculator. Let me just put in -1, see what happens. It's not going to be exactly -1. No, it didn't work. Alright. Well, anyways, if you draw the tangents, there'll be one vertical one here at about -1-ish, and then the other one be at around about 4, where the two vertical tangents are. Where would you say the two horizontal tangents would be? Where would be the top horizontal tangent? What value? Around about 2.2 or something like this, and then the lower horizontal tangent? No, I'd say a little positive, maybe like 0.2 or something like that. Maybe. It's hard to see. Anyways, there you go, you have your answer. That's what the graph looks like, oval shape. Okay, next now. You can write it down. You tell me. I'll just write down the points, but the description you can write down. So first, let's talk about the three descriptions here. So what happens in the first transformation here? Moves down 1 unit on the y-axis, of course. The second one compresses 3 times and then moves up 2 units. And the last one, it's 4 units this way expanded and then moves to the right 1 unit. Don't forget it's opposite on the inside. Alright, now okay, so I won't bother writing the sentences down for that. The calculation part. So the first, well, sure, we can probably do it in our heads. So the first one, if I move it down 1 unit, what would the point become? -3, -6. Yeah. The second one, when I compress it 3 times, what happens? It becomes -1, -5. And then if I add 2, I get -1 and -3. Good. And then the last one now, I expand 4 times vertically. So what would I get? -3 and -20. And then I move it to the right. So what would it be? -2 and 20. So you see, I'm not even going to bother to write it down because it's so similar to what we just did, and you can even do it in your head. And it's 8 marks. So that's handy. The more difficult part now, which I'll write down, is the B part. Oh, let me get the question up. So please write these down, px and qx. Okay, so now, what was the px? X minus 3. And then the qx was x squared minus 2x plus 5. Or what did I say, minus or plus? Plus. Okay, so they want you to calculate pq of 2. So I put the 2 into the q. 2 squared is 4. 4 minus 4 is 0. Plus 5 is 5. And then the 5 goes into the p. 5 minus 3, so that's a 2. And then we do it the opposite way now. First I put the 2 into the p. 2 minus 3 is minus 1. And then the minus 1 goes into the q. Minus 1 squared is 1. Minus 2 minus 1 is plus 2. So 1 plus 2 is 3. Plus 5 is 8. Right, just double check that. Minus 1 and 8. Oh, minus 1 and 8. Sorry, so I did this one wrong. Let's check it again. 2 squared is 4. 4 minus 4, 0, 5.
Don't change. Like this is only for Q, and then from the Q you put it into the Q.
Yeah, it is right. But let's just check here. Oh, sorry, there it is there. 2 and 8. That's what I got. Okay. Now, the more difficult part is solve PQ equal QP. So first we have to calculate PQ. So PQX equals P of Q. Now when I put this into the P, it just becomes x minus 3. So it'll be all of this minus 3. X squared minus 2x plus 5 minus 3. And then the opposite way now, putting the P into the Q. So P into the Q. X minus 3 goes into the Q. So you have x minus 3 squared minus 2 times x minus 3 plus 5. That'll be x squared minus 6x plus 9 minus 2x plus 6 plus 5. Yeah. What's wrong? Everybody looks so unhappy. The noise? Yeah. Where they got what now? 8. 8? Where? Here? That's the last question. But I'm doing something else now. Yes. Okay. Now, we have to make them equal. So this one equal to this one. PQ equal QP. So x squared minus 2x plus 2 equals, now this one, x squared minus 8x 20. Now, that's nice because they cancel. Take this over to the left. 8x minus 2x is 6x equal 18. So x equal 3. Right, last part now here. They want the inverse of the function p. Well, we kind of know this already. If my function is x minus 2, what's the reverse of that, or the inverse? Yeah, and that's the answer. No, in this case, because it's so easy and it's 1 mark, yes. But anything more than 1 mark, no. Go on.
Why didn't you just change it to?
Why didn't I do what now?
Why didn't you minus x plus 2?
What are you asking me? We're looking for the inverse here. So if I have a function whose job it is to take a number and then remove 2 from it, what would be the reverse of this? Yep. Got it? Yes. Where? It's really loud, isn't it? Like it's really good and loud. I wonder what it is. Ah, that's why. I'm not sure what the beeping is supposed to do because it's not like. Yes, it's not like.
If it's beating, it's supposed to go.
Yes, but it's not moving. It's just sitting there. Hey, look, I'm going in here until 5 o'clock, so you're okay. We just have a few more minutes to go. Yes. What's that? Yeah, but not in this room. Right? Oh, now I miss it. All right. Yeah, there we go. All right. 3 now. Did you write that down? No halas. Next one. Okay, so we want. But I think this one here is exactly the same in the other version, isn't it? This question here is exactly the same as what I did in version 1, isn't it? And what about the next part? Is that the same or different? It is. Oh yeah, because the other one had a square in it, didn't it? Yeah. So I'll do the A part. We have it done already. The B part is completely different, so I'll do that one now. So can you write this down and then this down as well? This and this. I don't know what you're saying, and I kind of feel like I don't want to know. Yes, we're doing those now. Okay, so firstly, we want to find the ABC, and then we'll integrate. Okay, so can you please read out to me what was the quadratic? 3x squared.
Minus 3x minus 2.
Yep.
X squared. And then
Wait, minus what?
minus 3x.
Plus 2. Okay, and it has 3 factors. So the first one was just A by itself. All right. Okay. Plus. Okay, and then finally. Okay. Now we know the story here. We multiply out by the denominator, so we'll end up with 3x squared minus 3x minus 2 equals A. Oh, I didn't check, but I assume when you multiply these two here, it makes this quadratic, which it does. Okay. Plus B times, not finished. A times x minus 1, x minus 2, plus B times x minus 2, plus c times x minus 1. Alright, that's it, isn't it?
How did you get x minus 1 and x minus 2 for the A?
Well, what I did is I multiplied everything by x minus 1 and x minus 2. There was nothing in the A to cancel, you know, so it just stayed there. Now, what should I choose for x, my first value?
1.
Yep, because that will cancel everything except for the b. So if I have here x equals 1, I'll get 3 minus 3 minus 2 equals 0, and then this will be minus 1 plus 0. And now we're moving. Therefore, b equals 2. Yeah? I got b equals 2. Now what should I use next for x? 2, yeah. So that one and that one will go. 2 minus 1 is 1, so that's just left with c. And then here I'll get 2 squared is 4 times 3 is 12. 12 minus 6 is 6 minus 2 is 4. So therefore c equals 4. And then finally, yep. So I get minus 2 equals this one times this one. So that's 2 times a, which I don't know, plus b times this one, which is, so that is minus 2 times b, so minus 4. And then c times this one, c is 4, so minus 4. So that'll be minus 8. Take it to the right, I get 8. 8 minus 2, 6. Divided by 2 is 3. So therefore, a equals 3 here. Let's check if that's right before I go ahead. I'll go back, don't worry. Where's my answers? Why didn't they give it to me? Oh, there it is there. The A is 3. Where's their B and C? Oh, there it is. 42. Oh, no, sorry. That's 2 marks. That should be over here. 2 and 4. Yeah. 2 and 4 and 3. Okay, so it's right. Now we want to integrate, and the limits are 3 to 4. Okay. So I'll go back up here, replacing these. So that is 3. That one is 2. Yeah, and then this one here is 4. Now this actually integration is not so bad, because this is just going to be what when you integrate it? 3x. And what rule will you need here? Log, and then this one here? Log. So this ends up being 3x plus 2 log x minus 1 plus 4 log x minus 2. Now what were the limits here? 3 and 4, wasn't it? So if I put the 4 in first, I'll get 12 plus 2 log 3 plus 4 log 2. And if I put the 3 in, I'll get 9 plus 2 log 2 plus 4 log 1. Well, that's 0, so that's gone. 12 minus 9 is 3 plus 2 log 3 plus 4 log 2 minus 2 log 2. So that's 3 plus 2 log 3 plus 2 log 2. Those 2's can go up as powers. So it'll be 3 plus log 9 plus log 4. And then when you multiply logs, what do you do? Oh, sorry. When you add logs, you multiply. So this will be 3 plus log 36. No, I don't know which way they write the answer. Oh no, yeah, you can actually they're not asking you to show that it equals something. So in fact, yeah, I can stop here. But you remember sometimes they say, show that the answer equals whatever. So is there anything else I could have done here if I had to continue? Well, what's 36? 6 squared. So I could have written this as 3 plus 2 log 6, because 6 squared, the 2 comes down. This is as simple as I can make it before I have to use my calculator then.
This antiderivative dividable, can you distribute it to?
Can you distribute it only in addition? So like if you had f plus g plus h, then yes, it distributes into the 3 of them, but not if it was f multiplied g multiplied h, or not if it was divide, only in addition and subtraction. And actually the word you were looking for to describe that is called linear, just like in geometry. So you could say, is integration linear? It means, can you distribute it in? It is. And also linear means you can take constants out in the front, which you also can. Okay, do you have that one written down? Let's see what they gave us for the answer. Yeah, there you go. 3 plus log 36. So I could have actually stopped exactly one line earlier. You got that? That was the last part, wasn't it? Yeah. How many marks for that, actually? Well, no, for the whole question. 6. And then the ABC was 4. So what I did was 10. Okay, sorry. Alright, what's next now? The vectors, I don't think I'll have time to do that one. What? You don't like this one?
They're easy, it's just they're so tedious.
Yeah, well you got 15 or 14 out of 15 by doing this properly. What's this? This is your salvation. This will help you get through the exam in 4 weeks. It's the statistics question. You need it. You need it. Alright. There's only 5 minutes left, so I don't have time to do another one. Yeah, nothing is going to happen in the next 5 minutes, I know. Okay, so look, guys, this revision book, how many, I put 8 papers in it, didn't I?
Which revision book?
What? No. No, that's for, did somebody take that?
No.
Did you take that?
I wrote my name.
There was somebody from Intake 2 looking for that book, and I said, where is it? And I said, I don't know, I left it there for you. I said, maybe somebody took it. Give it back to me.
No, I wrote my name.
No, I'm not taking out another one. Give it back to me.
I put correct on my name.
Alright, do that.
And I wrote book 2 and a ugly face and everything. Why? Why? I want one.
You have one. It's
No.
all worksheets
I
from
don't
semester
have
2.
them. They're scattered around planet Earth.
Like you.
Hey.
Whoa. Just go remove your name, please, before you make me angry.
You could say that if you wanted to have
Yeah, I did. To you. Don't pretend everybody knows.
like in here.
It's right. Come on, look inside.
No, all you have to do is wait for me to drop out of Intake 2 and then take the book off there, okay?
That's so bad.
I'm sure.
Can we get one? Yeah.
per month.
I didn't jump on.
But we're little. Yeah. What happened to get the...
We did get this. The only difference is that one has a staple and yours doesn't. I tell you what, if you want, I can go to the office and get 2 staples if you feel that that would give them to you. I don't mind, this is okay. I don't want you to feel like you got lost.
Fuck? Racism.
It's not racism.
No, you're preferring them.
Yeah, I prefer intake 1 student.
So you're supposed to let me keep this.
No.
I'm waiting.
No, okay.
Are you sure?
Yes, I'm
Really?
quite sure. Where did you think that was for you?
I don't know. I went and I saw book 2. I'm like, ooh. And I went and you know what I did? I did. What do I have?
Is this true?
I'm just inspiring you. I'm trying to motivate them.
Yes.
To study freaking math.
Yes,
I saw the book. You're taking the
Yes,
class.
yes. So terrible. Okay, so the revision book I was talking about, I put on Moodle at the bottom of the page.
Could you please print it for us?
No.
Show us.
It's on Moodle, it's at the bottom of the page, and it's a book that has past papers in it, and that's what I'm going through now. So I think I have 8 papers in it. So it's a good idea if you practice these at home rather than just seeing me do them, okay? So I've already done 1.5 of them now. There's I think 8 in total. No, I gave you something slightly different, didn't I? Yeah. Let me show you just before you go. Crazy students. Right. What did you say? Something really dirty?
No.
Alright. Now, as you go, just make note. That is the file, what it looks like. That's the revision book. So you can see, it's at the bottom of the page, and you've got... Actually, I think there's more than 8. There must be about 10... There's 10 different exams there, okay? And then at the very, very back page, I put a checklist. So you can check off the questions you've done. So we've actually done all of version 1 and some of version 2. But it's much better if you only check it off if you tried it yourself at home rather than seeing me do it, okay? So it's all there for you. I recommend doing all of these papers. If you do all of these papers, you should be fine.
I couldn't find the marking scheme for this.
I didn't put up a marking scheme.
Wow.
It's all, but you downloaded the marking schemes before, didn't you?
Not for version 2009, just for 2000.
I'll put them back up.
Yeah.
All right. See you tomorrow. All right. Do we have class tomorrow? Just on Friday.